Welcome to this Viessmann technical training presentation on the Vitodens 100 B1H and B1KA boilers. Today's presentation will cover the fault OB. And these are the boilers that we'll be talking about during the presentation. There are three boilers that essentially make up the 100 series of boiler with Viessmann. They're all space heating boilers. They all have the ability of heating your building based on the input that you require for your to maintain the comfortable living space. It also, all three boilers will provide domestic hot water production. The first two, the B1HA, will require an indirect tank be essentially installed, and it will heat the domestic hot water via the internal heat exchanger in the tank. The 100 boilers B1H94 or B1HA125 will come with a sensor, domestic hot water sensor, that you can utilize for domestic hot water operation, or the alternative there where you could use an aquastat, wire that to the boiler, and can operate off of an aquastat for domestic hot water production as well. The B1KA boiler, a little bit different in it has a heat exchanger built in. Potable water is directly piped to the boiler, and as you open up a fixture faucet, that water flows through the heat exchanger on one side, potable water. The other side is the boiler water will flow through, and we'll heat that water up basically on an on-demand basis. So as you need water, it is basically being heated as the fixture is open. And this slide are just some technical bits of information that come with the boiler documentation. The reason why I'm putting this slide up is to kind of focus in on the minimum boiler operating pressure. Pressure has an influence on your boiler as far as operation, and it is one of those factors that could cause an OB fault. And you'll notice that we do have a minimum boiler operating pressure recommended of about 12 pounds. That could be different based on the expansion tank that you use, static height in your system, but there is a minimum that we recommend of 12 pounds. You'll see it in the technical documentation that we have here. And just another slide with a little bit more technical information included on it. And but the idea here is to really focus in on the OB fault factors, and flow rate would be another factor that would cause the OB fault to occur on your boiler. Here we see the maximum flow rate of 6.2 gallons a minute. As we go through the presentation, we will find out the other side of that, which is the minimum flow rates. We need to kind of get a hold of both minimum and maximum flow rates and know that the boiler is operating within those to avoid having the OB fault occur. And this is what you would walk into if a boiler was locked out on an OB fault. This would be the screen on the display of the boiler. You would see the F and the colon and the OB, along with the triangle fault output, basically message that would be flashing on the screen. Whether it's a new install that you've just started up and you've powered it up and you have the OB fault, or the boiler's been installed for some time, essentially the troubleshooting is fairly similar. We need to go through the different aspects that could cause the OB fault and just isolate those particular aspects and eliminate them until we come up with the reason why we've got the OB fault on the display. When you see that display on the boiler, the OB fault, what is the boiler trying to tell you the issue is? In order for us to discover that, you need to go into the manual that comes with the boiler. If the manuals aren't available for whatever reason, there's also manuals available online. We have the Viessmann Orange app available for you. There'll be a bit of detail at the end of this presentation on the Orange app as well. Viessmann.ca, our website, we store all of our manuals, everything current as well as historical products. We have the manuals available. They are 24 hours a day, 7 days a week, 365 days a year. So the manual here is located. It's the installation and service instructions for the 100 boiler. This is where the fault and troubleshooting information will be located. Just to kind of highlight that OB fault that's in the manual and blow it up here a bit so you can see it. The The OB fault will result in the burner being blocked, so there will be no boiler firing, no heat for domestic or space heating as the OB fault is occurring. The situation is there is a low water condition, so we're either at low pressure, we either have a defective pump or a flow switch. Could be multiples of that. We're troubleshooting here, so we need to isolate, eliminate each one of these factors from the equation to make sure that we come up with the right solution. So we're going to go through the process here basically of checking the water pressure, your pump, and your flow switch with regards to this particular fault. Now here's a visual of those three components. The pressure gauge is on the left-hand side of the screen here. That is built into the boiler as well. So this gives us essentially a visual of what the pressure is in the boiler, associated system pressure. The boiler pump itself built in, so this comes with every 100 boiler, the UPS 1578 Grundfos pump, and the flow switch. So these are the three items that we're going to have a look at, work through these to come up with a solution for this OB fault. Three areas we have to look at. Coming back to this previous slide and kind of focusing on the pressure. So what is the pressure in the system? Let's have a look at that. Very simple. Have a peek at the pressure gauge. We identify what that pressure is. And of course, we don't want to see that pressure at zero. That's a pretty good indication that this was the reason why your boiler was not going to fire, because we don't have any pressure in the system itself. We need to get that pressure basically up to that minimum of 12 psi, which is recommended. Some tank manufacturers, expansion tank, diaphragm, expansion tank manufacturers also recommend that you give it about a 3-pound higher system pressure than the actual pressure in the tank. That allows the bladder inside of the diaphragm inside of that tank to flex, essentially, so you don't have rapid fluctuations in pressure, etc., as the boiler water heats up, etc. So essentially, what we're looking for there is, somewhere around in a typical system here, in a residential application, 15, 16 pounds would be an ideal pressure in your system, but minimum recommended is 12. Also, the air in the system may be a problem. So if it's a commissioning issue, for instance, or if you had a leak in the system, that's why your pressure is dropping, or you've just started the boiler up and just started basically entering the water into the boiler to get it up and running, there is in our manual a fairly detailed page that covers how to properly purge the boiler. In the installation package, we actually supply you with sediment faucets, essentially, to be able to purge the boiler, isolate it, and purge the unit individual of the system, so you can get that air out of that boiler. There's also a keyed air vent at the top, which you can open up and essentially get any residual air at the top of the heat exchanger out. The whole idea here, the whole key, is to be able to ensure that once we turn the boiler on, that circulator that's built in is actually going to be able to move the water around sufficiently enough that the flow switch will close. So if that flow switch doesn't close, the boiler is not going to fire. If there's air in the system, that's going to impede that process. So we need to get that air out. There is actually beyond the just straight purging of the boiler and getting the pressure up, there's also a venting mode or a filling mode that's available in configuration on the 100 boilers. And in order to access that, so here's a little slide that kind of shows you what that's going to do essentially in the programming. So item number 1 is what we're focusing on here. And when we're doing a commission of a heating system, this is an excellent opportunity to use the filling function. Basically, in the manual, it details how to get into that. We need to push the mode key first, and that is going to essentially get us in the area where we can start to search for config or confi on the screen. Push the mode button, toggle with the up and down arrow keys until confi is actually flashing on the screen. Then press the OK button. That will change the screen now to the P with the colons and the 2 zeros flashing. use the up arrow key and change those zeros to 12 and then press OK. That gets you into the configuration area of the boiler, so where you can start to do some of the different programming. We're really focused in on just that first one here for this particular presentation. What we want to do is once we get the password in there, 12, and push the OK button, then we're going to have the screen change to where there's a 1 and then a colon and a couple of zeros. And we can push the OK button to get those zeros flashing and then adjust it with the up arrow key to 1 and press OK. What this will do is it'll put your boiler into a filling function. The pump inside of the boiler will now manually run for about 30 minutes or until you power the boiler off. And the diverting valve inside the boiler will position itself so that it can purge the air out of both the domestic side and the space heating side. If you have domestic and space heating, it will purge both simultaneously. And that will essentially ensure beyond the purge tees and the manual keyed air vent in the boiler, this is another area where we can move the fluid around to get that air out of the air vents that are inside of the boiler as well as in your system. During this process, it's also recommended that you back the little set screw that's in the middle of the circulator out and purge the air out of the pump as well. This will ensure that that pump has reliable operation and minimize the possibilities where the pump will stop working. There's our picture of the flow switch sitting inside of the boiler, and open up the unit here on the right hand side and kind of give you an idea where that flow switch actually sits. Essentially it's in the flow of water. There's a paddle that is part of the flow switch itself that you don't see when it's immersed in the piping. And as the fluid moves past, if the flow rate is correct, that paddle is going to close, essentially going to complete a circuit. It's going to feed back to the boiler control saying that we have flow. It's now safe to release the burner for ignition. If that flow switch stays in the open position with a call for heat, that's when the OB fault is going to occur. Or for us to get an idea of what that minimum flow rate is, there is actually a sticker that's on the flow switch. If we read that sticker, it tells us that that minimum set point is 300 liters an hour. So 300 liters an hour, about 1.32 gallons a minute is our minimum. So if we have no flow or we're below 1.32 gallons a minute, the OB fault will occur if we have the call for heat. Now we see the flow switch wiring connection in this particular slide, and you can see it's identified with a 33 plug. So any wiring schematics that you may see or use in the manuals or the wiring schematic that's on the boiler, the 33 plug basically identifies where the flow switch is wired back to the control console. Essentially when there is a call for heat and that flow switch closes, all it's doing is sending a closed contact or just continuity, verification of flow. Very simple test. You remove the 33 connection from the flow switch and you can do a continuity test across your flow switch. Essentially if it's closed, you'll hear an audible beep or some sort of signal from your meter that there is a closed contact. If it does not beep, stays in open, you have that open circuit. We do have a test that is possible where you can jump the 33 plug, and that will actually initiate a call for essentially release the burner for operation. And that is strictly a test here, not to be left in place because it is a safety we're dealing with here. But for testing purposes, we can bypass the flow switch here and the burner will fire up. And if the boiler fires and modulates and runs to set point, everything is in normal operation, that's usually a good indication that your flow switch is the problem. Very simple at that point to isolate the boiler, drop the pressure down, remove the flow switch, inspect it to see where the problem may be. At that point, replace it and put the boiler back into operation. If, however, you jump the flow switch and instead of normal operation, the boiler trips on an F2 fault, basically a fixed high limit fault, because the boiler overheated, that would be a pretty strong indication that there is no flow in the boiler. So the flow switch is staying open because there's no water flowing past the paddle to actually close it. So we're not getting the heat away from the boiler fast enough and we trip on the F2 fault. So if that's the case, we're looking down now at the circulator and the pump inside the boiler, whether it's a B1HA, built in, or B1K built in as well. We can see it here in the little diagram. To troubleshoot the pump in an OB fault situation, a couple of things to look for. Obviously, is the pump powered? So we can check for voltage at the pump itself to make sure we've got voltage. Another easy test method is to check for amp draw. So I show you in the left-hand side there a clamp-on ammeter, which is connected basically to the line voltage out cable to the pump. And the pump itself on the face have all of the different amp draws based on the different speeds that the pump is capable of. We're always at speed 3, remember, and essentially what we're looking for here is a comparison. So you take an amp draw and compare it to what the face of the pump indicates the amp draw should be. A very low amp draw here, comparison to what you see on the face of the pump, could indicate something like a sheared impeller, or possibly a valve or some sort of isolation valve that's closed with the pump is deadheading. If you have a very high amp draw here, you may also notice that the pump is quite hot to the touch. That is usually the pump is starting to seize up. Of course, you start to overdraw amps, it gets a little bit warm. So basically at that point, with an OB fault and you've tested your pressure and your flow switch, the next step here is to have a look at how that pump is performing as far as its operation. Having a look at the pump performance curve for the UPS 1578, which is on the left-hand side of your screen, the pump will come from the factory preset to the maximum or speed 3. We have a second curve that we document in our manuals as well, which is now on the screen. And essentially it maps out or tells you if we want to maintain the maximum of 6.2 gallons a minute, any associated piping connected to the boiler cannot exceed 4.7 feet of head. So whatever we attach to the boiler as far as piping, this is the residual head that's left over to push that fluid around that piping in order to maintain the flow rate that we're looking for. So if we exceed 4.7 feet of head, we are not going to maintain 6.2 gallons a minute. With that same curve on the screen, what we can do now is set our parameters for flow rate. Essentially now with the shaded area in the red, which is below 1.32 gallons a minute, that's our minimum to keep the flow switch closed, up to 6.2 gallons a minute. We need to keep the flow rate in that white area. So we start getting into the red area, that flow switch is going to start to open, and we're going to get into an OB fault situation on our boiler. The advantage of primary secondary piping in this case, and I've thrown up a couple of examples on the screen here of either closely spaced tees or using a Viessmann low loss header on the left hand side here. The advantage of using primary secondary piping is the pump inside of the boiler maintains a constant flow rate. So regardless of the call for heat, when that pump comes on, the flow rate will always be the same. Comparing a primary-secondary system to a non-primary-secondary system, we have an example here up on the screen of a 4-zone system, non-primary-secondary, so that pump inside the boiler will also push the water through the heating system. And how things operate here is as a zone, as thermostat calls for heat, zone valves will open and close, typical. But as these valves in this particular setup are opening and closing, the flow rate is changing through the boiler. The pressure drop through the system is also changing. It's very difficult for you to know what the flow rate is or the pressure drop at any point in time in a system like this. If you have enough zones and possibly enough pressure drop through those particular zones, as these 1 or 2 single zones open, you may actually get into that red area in the curve here. So there's not enough residual head to move the minimum amount of flow rate through that particular zone. Characteristically, what will happen here sometimes is when that zone opens, the boiler will not fire, but as another zone opens, there's enough flow rate there that now the boiler will fire. So you get an intermittent OB fault in your system. And the problem here is that there is not enough flow through that one single zone for the boiler to fire to operate. I hope you found that information useful. I want to move on to our website right now. This is an area that you can find information to help you in your troubleshooting, whether it's a 100 boiler or one of our other many products that we have. The website's Viessmann.ca. You see it on the screen here right now. There are different areas here. I recommend you click on the right-hand side, the menu, highlighted in orange. And when you click on that menu, it's going to open up the window on the right-hand side here, and the top area you see Pro Toolbox. I would click on that next. And in the Pro Toolbox area, you'll see that we have all of our manuals. Anything that we sell today in the current product manual area, the documents will be stored there. Anything that's past product, we don't sell anymore, but you're going to be doing service and troubleshooting on, those manuals will be in the historic area. We also have a fault code checker that's available on our website. You'll see it there, and you can key in any faults that you see on the boiler control, and it's going to give you a verbatim of what the actual manual will tell you that fault is. So lots of useful information in here, different videos as well, as you can see down at the bottom, contractor training videos. So a very useful area for you to know about to get access to information. Our tech info line is 888-484-8643. If you have either troubleshooting and you need additional assistance above the manual, make sure you have this number handy. You can give us a call and we will support you to get that boiler up and running. And finally, we have the Viessmann Orange app. This app's intended for your phone, tablets, laptops, or desktop. You can put it right on there. The link is just below there on the screen. And you can sign up, log in here, register for it, and it just essentially puts Viessmann right on your device. Everything from registering for academies, basically manuals, troubleshooting, direct contact to our tech info line, all that stuff will be now on your app, which is going to be located right on your phone. So it just makes it a little bit easier for you to get in contact or make connection with us here at Viessmann. So thank you very much for your time, and we will continue this technical training presentation series. So look forward to it in the future. Thank you. Bye-bye.